and have joined Google around almost 2 years back. In today's session, I'll start by giving an overview of challenges with the legacy databases and how GCP database portfolio can help overcome these challenges, followed by a comprehensive step-by-step database migration process that we designed to make the migration and onboarding to GCP native databases smoother and easier. In traditional on-prem databases, we see a lot of unpredictabilities. And these unpredictabilities can be of any form, like, for example, a natural disaster, a human error, right? And to solve all these unpredictabilities, it's a huge effort. Like, for example, how do we solve a natural disaster? We can solve it by planning a DR strategy. But if you have an on-prem database, it's very difficult and cost impacting to have a DR strategy planned from an on-prem database. So you require intensive operation and management on the traditional databases. They are typically built with monolithic architectures that do not scale globally. They are prone to downtime and require specialized expertise to keep systems highly available. TCO is pretty high due to inflexible and pricey licensing models. And even they are unable to quickly respond to security vulnerabilities and regulations. So to take on these unpredictabilities, we have to modernize the existing database solutions. A first step towards this modernization journey is to move to a fully managed, highly available database that scales online based on the traffic and very, very importantly, allows you to pay for only what you use when you use it. Okay. And all these features and capabilities, what I just spoke about, are fulfilled in GCP database portfolio. So let's try to understand and have a deeper look as to what is a GCP database portfolio. Broadly speaking, we have categorized the entire portfolio into two categories. The first are the set of traditional databases. And when I mean traditional databases, I mean the databases which we have been using for past so many years, like MySQL, Postgres, Oracle. Okay, and these are typically to offer you the ease of migration and compatibility. So because if you try to move from if you try to migrate to a different database engine, it's very complex, right? So the first step towards moving to any cloud could be to first have a migration to a homogeneous engine and then try to modernize yourself. Okay, so the first category are a set of traditional databases, which is Cloud SQL. Cloud SQL has multiple offerings like MySQL, Postgres, and SQL Server, and bare metal solutions that we have Oracle. So this is our traditional offering. The second category is our cloud native databases. Here what we have done is we have made available our own Google built databases and made them available as service to our customers. They offer unique online unlimited scale and industry leading availability. In addition, we offer a caching service with Cloud Memorystore, which supports both Redis and Memcached. And finally, to complete the portfolio, we are working very closely with our partners such as MongoDB, Neo4j, InfluxData to provide integrated support for database applications such as document, graph, time series. Okay, so let's start by looking at few of these services and also focusing specifically on what are some of their differentiators. Okay, so Cloud SQL. Cloud SQL is a fully managed relational database service on top of MySQL, PostgreSQL, and SQL Server. So if you're using, if you are on-prem and managing MySQL database, a self-managed MySQL database, you can easily migrate to Cloud SQL MySQL. If you're on Postgres, you can move to Cloud SQL Postgres. Similarly, if you're on any cloud and you are on a managed offering of Postgres, you can move to Cloud SQL Postgres. And similarly, it goes with SQL Server. Now let's start looking at some of its differentiator. See, whenever we talk about databases, right, and whenever we try to do a capacity planning for it, we either do a 8 core 16 GB or the next option what we see is 16 cores, 32 GB, or the next option, if the requirement is really big, we go with 64 cores, correct? But at any point of time, do you really think that we use all the infrastructure? We don't, correct? And so, sorry, because we have very less choices to choose from, at least in terms of the t-shirt sizes of the database available on different cloud, we end up wasting a lot of resources, which cost us a lot also, right? So one of a very important differentiator of Cloud SQL is that you get to choose your own t-shirt size. And what it means is you can just go ahead with 12 cores, 14 cores, 16 cores, 18 cores, whatever is your requirement. So when you do a capacity planning, right, you can choose based on the NFRs what you have defined for your database. You can choose your own t-shirt size in database, and so you would always be optimally using the hardware infrastructure that you have provisioned. Okay. Another differentiator or another property of Cloud SQL is that you get in a single instance of Cloud SQL, you get to vertically scale up to almost 96 cores of CPU and 624 GB of RAM. That is for a single Cloud SQL instance, either it's MySQL, Postgres, or SQL Server. Another differentiator of Cloud SQL is, see, because whenever you are planning for a database, right, there are certain aspects to it whenever you are doing a capacity planning. And typically it is in terms of, like, for example, IOPS, correct? So how much of an operations you would be doing, based on that you size, correct? But when you try to create a database instance in any other cloud or in on-prem, how do you figure out how much IOPS will you be able to get? Okay, I do understand it depends upon your payload size also, and multiple other factors like the disks, hardware, whatever underneath you have, but still it would also be dependent on how much of an IOPS that you intend to do. Okay, this is a very important thing in deciding as to what should be my database capacity, correct? So the best part about Cloud SQL is that whenever you are spawning a Cloud SQL instance, and as soon as you put your details in terms of the number of cores, storage, and RAM what you need, Cloud SQL console would be able to tell you how much of an IOPS you would be able to get out of that instance what you are trying to configure. For example, as shown in the slide, if you choose 96 cores, 624 GB and 64 terabyte of storage, you get 85,000 IOPS. IOPS is input output per second, right? So you get 85,000 IOPS. But then another question could be, how much of a read IOPS I get? How much of a write IOPS I get? Does any cloud provider provide you that? So it's only GCP's Cloud SQL that helps you in getting you those details upfront. So if you see the screenshot, it clearly tells you that an instance of size 96 cores and 624 GB and 64 TB would be able to give you 60,000 reads per second and 25,000 writes per second, right? So this detail is really, really very important to make sure that your database is optimally sized. Okay, so it's a very important factor and a differentiator of Cloud SQL. Another very important thing what you get with Cloud SQL is resiliencies. Okay, so whenever you talk about database which actually holds your entire data, right, which is the most important piece in the entire tech stack, correct? So you also, as a database engineer, you should always try to create resiliencies at every point. And what do you mean by resiliencies? So the resiliencies could be, say for example, if a zone fails, okay, how do you recover your data? Okay, if you are on that particular zone and if there is an outage in that particular zone, then you would lose the entire data, right? So you need to plan a resiliency. Similarly, another resiliency could be that by mistake someone deletes or someone drops a table, correct? How do you recover that table, right? So you need to plan those resiliencies, and those resiliencies are just not key. We can always recover from a backup, right? It also depends what is your RPO and RTO. Based on that, you design your resiliencies. So resiliencies out of the box in Cloud SQL is provided to you in multiple ways. So like a zonal resiliency is provided to you through HA, high availability. What it typically means is there is an option available. So whenever you are configuring a Cloud SQL instance, there's just a button that you need to click, and automatically it will spawn an HA instance for you, which will give you resiliency from um, uh, uh, any issues with that particular zone. Another resiliency, what Cloud SQL also provides, and this is because Google Cloud has two regions in India. Okay, one is in Mumbai, another is in Delhi. So in case you have an app or you're trying to build an app which has data residency constraints, which means that you cannot move the data out of India. So you need to plan a regional resiliency in India itself. So because Google Cloud has two regions in India, you can plan a regional resiliency using something called as cross-region read replica. So what it means is you would be able to create a read replica in another region than your master. So if your master is in Mumbai, you can create a cross-region read replica in Delhi. So that will also protect you from any regional failures with minimal RPO and RTO. The third very important thing is how is a OLTP database like Cloud SQL is integrated with the downstream application. So what does it mean? So it means, see, any OLTP database is not great to have reporting queries being run on top of that, because for reporting queries, you need to have a different schema, unlike a OLTP schema, correct? So you should always make sure that all your reporting and analytics are being done on a OLAP system, not a OLTP system. Okay. But the question would be, how do I move, or how do I continuously replicate my data from OLTP to OLAP, right? In GCP, we have multiple OLTP databases, like I mentioned, like for example, Cloud SQL. So how do I move my data from OLTP, that is Cloud SQL, to a OLAP, that is BigQuery, which is a data warehouse? How do you move the data? So we have something called as Cloud SQL Federation. Okay, what it means is, to simplify the concept, okay, and how it typically works is that it's just like a database link. Okay, so you define a link in BigQuery to your existing Cloud SQL instance, and you would be able to execute a query on BQ console, which gets executed on Cloud SQL. I mean Postgres or MySQL or SQL Server. And the best part is you would be able to fetch the data out of a Cloud SQL into BQ, and you can store it as a particular table. And if you schedule it on a frequently basis, you would be automatically be able to get data out of these OLTP database to OLAP. So you don't have to maintain an explicit pipeline. You can just schedule these jobs, and automatically the data would be pulled into the analytical OLAP DWH solution, that is BQ. Okay, so the downstream integration is very neat with Cloud SQL. So now that we have understood the differentiators and what Cloud SQL is, let's also try to understand typically what are those, I mean, where it is typically used. Okay, so web or mobile apps, because it needs, because you need a database that is able to handle all the surge in the traffic, right? So all the mobile and web apps are using Cloud SQL. Another use case could be like a SaaS platform. So because it's a decentralized data management which Cloud SQL offers, so a lot of SaaS platforms are using Cloud SQL. And also we have observed that a lot of retail customers are also using, because of the availability and the reliability what Cloud SQL offers. So typically these are all the use cases where Cloud SQL is heavily being used. Okay, now let's move to another database offering. What we have is Cloud SQL Memorystore. Okay, so Cloud SQL Memorystore, what is it? It's a in-memory database. It's a managed Redis that Google brings for you. So traditional databases rely on disk-based storage, and a single user action may consist of multiple database calls. So as they accumulate, latency increases. However, by accessing data in memory, In-memory data store provide higher throughput and lower latency. In fact, in-memory data stores can be 1 to 2 orders of magnitude faster than the disk-based databases. So Cloud Memorystore for Redis provides fast, scalable, highly available, secure, fully managed, and supported by Google. So now the open source Redis is fully managed and it's offered to you as a offering on top of Google Cloud. So what are the typical use cases which uses Memorystore, right? So gaming customers like leaderboard or an advertisement, social media like chats or news feed, IoT use cases, or analytical use cases, the read heavy dashboards and such use cases, right? All these are using Memorystore. Okay, now let's talk about the third offering, which is Cloud Spanner. And this is one of Google Cloud native offering. Okay. So we talked about the issues with the legacy databases, the unpredictabilities with the legacy databases. And they're not, we also saw that, they are not quite equipped to handle any sort of unpredictabilities which might impact your business. And the impact could be major downtime, or even challenges with the scalability. Right? So you need a database that can back your business, power next generation applications, and leaves all the management to somebody else without breaking the bank. So you don't have to worry about quick shifts any longer. With other databases, you end up having to pick between scale, consistency, or management free. You just can't have everything. Okay. But this was the case only until Google created Spanner. Okay, so let's try to understand how does and what does Google Spanner solves. So Google's Cloud Spanner is a fully managed, globally distributed relational database service that scales horizontally and is strongly consistent and is ANSI SQL compliant. Right? So you talk about a database like MySQL or Postgres. What is the typical challenge we get? The typical challenge is that once the traffic increases on MySQL or Postgres after a certain time, you start to see performance issues, right? So you need a database that can horizontally scale, right? Typically, the horizontal scalability as a concept is mostly popular in the NoSQL databases. But Cloud Spanner is one of an RDBMS database that gives you the best of the NoSQL and the RDBMS world. It gives you the horizontal scalability, plus it gives you the ACID compliance and the relational semantics and strong consistency and 5 nines of availability, right? So this is what best you can ask for. On top of all these benefits, Cloud Spanner is also globally distributed. What it means is you can have it as a master database where one master can be on one region, another master can be in another region. Okay. So with globally distribution, also it provides you strong consistency. Spanner is very simple to use and manage. So you can build applications that transform your business while lowering your total cost of ownership. That is TCO. So let's have a quick comparison. So traditional relational databases, it's very difficult to scale them. It's only vertical scalability that is possible. Okay. And when I say vertical scalability, it means if your traffic increases, you can scale from 16 cores to 20 cores, 24 cores, 32 cores, right? But that needs a downtime. Similarly, if you go with a no relational database, you wouldn't get strong consistency. You have to go with eventual consistency. Or in databases like Cassandra or Scylla, you can tune your consistency, but that would increase the latencies. Correct? So you have to choose what you want to use. You can't have all. But when you talk about Cloud Spanner, you can get replication, you can get horizontal scalability, you can get strong consistency. So for example, if you have 2 Spanner nodes today and you think that there would be a surge in the traffic, so you want to add more nodes, you just have to go and click a button which says that currently you have 2 Spanner nodes and you want to scale it up to 4. So you just replace 2 with 4 and automatically your Spanner would be scaled up without any downtime. Okay, so It's that easy to horizontally scale your spanner. And the internally how we have designed spanner is there is a clear segregation of the compute and the storage layer. Okay, so it means that when you try to add more nodes, it's not the data that is moved across the nodes. It's only a metadata about these nodes which gets moved across the new computes that you have added. And that's the reason the addition or the removal of the node is super fast. Okay, and it's really very easy to manage. Okay, you also have auto scaling capabilities where you can configure the auto scaling aspect of Cloud Spanner, which will automatically add or remove nodes based on your traffic. So that's also available. In the recent past, we have had some feedbacks based on some of the functionalities that our customers expected. And so what we have done is recently we have done a lot of new feature addition in Spanner's portfolio. The first great feature what was launched recently was the granular sizing. Okay, so as a feedback, what we got to know is there are certain customers who doesn't want one complete node of Spanner. They said that we just don't want a complete node, whereas we need a part of a node. Okay, which will, because we don't have that much traffic currently. In near future we might get it, so we want to use Spanner, but we don't want to use a complete node of Spanner. And because we are not using that entire node, even we would be charged more because we'll be charged for that entire node. So can you reduce the size of a node, or can we actually spawn a fraction of a node so that we would be charged based on that fraction? So what we did is we actually released a feature where you can even go with granular sizing. So now if you spawn a Spanner instance, you can just go and say that I don't want one node, I need 1/10th of a node. Okay, and so you would be charged only 1/10th. You wouldn't be charged for that entire node. And with this granular sizing, the Spanner's cost is reduced by 90%. And now you can float a Spanner instance with just minimal cost of $65 per month. Another feature what we have recently launched is it's a PostgreSQL interface for Spanner. Okay, see, again, with OLTP databases like Postgres, the typical issue what we face is once we reach to a concurrency in probably 4 digits or the number of connections there, we start seeing some of the performance issues. Correct. And also when you want to scale it, you have to undergo a downtime, like a vertical scalability would need a downtime. So again, you wouldn't be able to go, you won't be able to do a horizontal scalability of your database. To solve this problem, what we have done is we have released a PostgreSQL interface for Spanner. And what it means is, see, if your application is currently using Postgres, okay, you don't have to change anything apart from the endpoints. You can use the same code. With the help of the interface, you can connect to Spanner now. Okay, because typically what we have seen is that there is a lot of hesitation in moving or migrating a database to altogether a different engine. Okay, so to make this migration easier and give you all those flexibility, what we have done is you don't even have to do that. You can just use a PostgreSQL interface so that you can use your existing Postgres code but get all the benefits of Spanner. Okay, like the horizontal scalability and all the benefits what we spoke about, you can get all these benefits. The third is Spanner CDC. Okay, so see, when we talk about a database, it's really important that we also think about how it would be integrated with the downstream application, like we were seeing in the case of Cloud SQL, right? So one option could be CDC, like whenever you make a change, it gets logged into a log, and from that you can have a utility which can read those logs, a transaction logs, and take that entire data and push it to any downstream application, maybe a Kafka or a OLAP or anything, right? So for that you really need a CDC feature. Okay, so Spanner has recently also launched the Spanner CDC, through which we can actually, there are certain APIs that are being exposed, which you can read and try to get all the changed data and push it to any downstream application. Okay, so what are the typical common use cases that we see where Cloud Spanner is being used? So any cloud native apps, SaaS platforms, or gaming use cases where you need a horizontal scalability, the surge in the traffic pattern, or the traffic patterns are really you can't predict those, and where you need high availability and very low TCO. So all these are some of the use cases where Spanner is being heavily used. Another cloud native offering of Google Cloud is Bigtable. So Bigtable is a fully managed NoSQL database service for use cases where low latency, scalability, and reliability are critical. Bigtable scales seamlessly from your first gigabyte to petabyte scale. Okay. So it is common for application traffic to see expected as well as unexpected peaks, right? So being a managed service, Bigtable makes it easy to scale performance to meet needs over time. Adding and removing node in Bigtable increases or decreases the traffic in a chunks of 10,000. So if your use case has a need of 20,000 IOPS per second, you can just go ahead with 2 Bigtable nodes. If you want 30, typically you just add one more node and it becomes 30,000. If you want just 10,000, you remove a node and you would be able to get just 10,000 requests. So in a chunk of 10,000, you would be able to add or remove nodes. Let's see some of the differentiator what we have in Bigtable in comparison to other NoSQL databases. Okay, so so in NoSQL, like in RDBMS, you have tables. In NoSQL, we call it as column families. So a table can have one column family in certain NoSQL databases, but what Bigtable offers is multiple column families in a table, which gives you a lot of data modeling flexibility. And because you can have multiple column families, you can have your properties per column family defined. Okay. Whereas in other NoSQL databases, you actually have to define the table properties, like the column family properties similar to a table properties. Another challenge what I see with NoSQL databases is how do you manage them? How do you make sure that your data model is correct? See, when you start an application, when the traffic is pretty low, everything works fine. But once you scale, you start seeing a lot of challenges, right? So you always need to make sure that you have a visibility engine with you, right? Where you can see, that if there is hot spotting that is happening, how much load a particular row in a particular column family during the peak, what is that traffic on a particular row. So all such metrics, you really need to have a visualization tool. It's very difficult to execute commands and try to get that information, because that is going to be real time. That's not going to be historical. But if you want to see what are the historical patterns, you need a visualization layer where the data is stored, and it's really easy to get all those details out. So Bigtable has, for such visualization or validation of your data model, you have something called as key visualizer. So it's a graphical tool that gives you a clear visibility into what are your access patterns, and if there is an issue with your access patterns. Then you also have certain limitations with certain NoSQL databases, like in terms of row sizes. But Bigtable is pretty open with that, and the limitation what Bigtable offers is, I think, 10 times more than other NoSQL databases. Then when you spawn a Bigtable instance, you have to make clusters. So you can have a multi-cluster implementation, you can have a single cluster implementation. So within a single cluster implementation, Bigtable guarantees strong consistency, although being a NoSQL database. Okay, so if you have a use case where you want to have high velocity of data coming in, you need low latency, but you need strong consistency. Okay, Bigtable single cluster implementation is the way to go forward. Let's see some of the use cases where Bigtable is used. So ad tech and user analytics, where the volume is really high and you really need very low latencies in terms of writes. So ad tech and user analytics, financial or risk analysis, or IoT use cases. These are some of the very common use cases where Bigtable is being used. Another Google's native database offering what we have is Firestore. So for rapid app development, we offer Firestore, our fully managed, scalable, serverless document database. Firestore is beloved by developers because of its ability to serve both as a document database and backend as a service. Firestore enables offline support with real-time synchronization. An example of the popularity of Firestore is that Firestore has more than 250K monthly active developers. Okay, and they have like almost 750M monthly active end users using Firebase authentication. So that's how popular it is. And it's really very easy to develop apps using Firestore, and that is the whole reason why, if you see the common use cases where Firestore is being used, it's all the web and the mobile application that is being designed, and the ease with which Firestore solves all the complexity there. And in fact, also some of the IoT use cases where you just need to pump the data to a database using some endpoint. So these are some of the common use cases where Firestore is really popular. Okay, so with all this overview of the entire database portfolio, now the next question is, yes, all these databases are great, they have all those differentiators, that's fine, but how do we get onboarded? Correct, that might be a question. Okay, so let's spend few minutes in understanding how the migration journey looks like and how easy it is to move to a native database on GCP. So we do understand the migration of database is not trivial, but the benefits are game changers. And so we have created a comprehensive roadmap for migrating your databases to any GCP database offering, like for example, Spanner, to make the journey as smooth as possible. We have a detailed plan starting from assessment of source databases using automated tools till refactoring of the application code using external tools. Okay, so let's understand how this entire migration journey works. So whenever you decide that we have to move to a Google Cloud's database offering, we execute certain assessments. And what do we get out of these assessments? So when we execute these assessments, the deliverables we provide you at the end of the assessments are, number one is strategic. What it means is this is primary for the executive level and covers business impact, migration time, all those things. The second deliverable what we provide is financial deliverable, which is typically a TCO impact document covering the migration cost, lift and shift. The third is the technical report. For technical perspective, we provide the deployment architecture that helps you to migrate with minimal downtime, mapping from source to target as you might migrate from one database engine to another. A very comprehensive report is generated to help you smoothen your migration journey. In terms of timelines, these assessments are led and managed by Google. We bring the tooling that is Migvisor, for example, to do the discovery and scoping phase, define the complexity score, and then plan your migration and the associated tools. So this is how we assess your source databases. But the question could be, what tools would be, once the assessment is done, what tools will you be using to migrate the databases or refactoring the code in case there is a change in the database engine? For example, you are moving from Postgres to Spanner, okay? And you don't want to use a Postgres interface, whereas you want to migrate everything. So how do you do those changes, the application code changes, the data migration? How do you do that? right? Sorry. So broadly, if you look at the database migrations, it can be classified as heterogeneous or homogeneous migrations. So heterogeneous migrations are where the database engine changes, and homogeneous is we just do a lift and shift, keeping the source and the target engine same. Okay. So for homogeneous migrations, we have a tool called as Stratozone. We execute the Stratozone on your source database to do all sort of discoveries in terms of what are the different, let's take an example of Postgres. So what are the different database parameters that you have set? What are the extensions that you are using? What is a database character set that you are using? All the basic information of databases that we'll fetch. And then what we'll do is we'll try to do a comparison. Okay, and we'll give you a complete assessment report, which also would include the recommendations and the TCO analysis. And once it is done, then we can use certain tools to migrate your data. With respect to heterogeneous migrations, it becomes a bit complex because the assessment remains the same, but we also have some extra steps like schema conversion. For example, in one database engine, there would be a data type which might not be supported in, or which might be with a different name in a different engine, correct? Like in MySQL to Postgres or Postgres to Spanner, right? So you have to make sure that you change the schema, okay? So you have an extra step of doing that schema conversion. So once the schema is migrated, then we'll migrate the data. But once we migrate the data, there would also be some business logic. Okay, either that logic could reside in the database or that logic could reside in the application. Ideally, the best practice says that the entire logic should be in the application, but never in the database. The database should just store your data, not the business logic. But still, if you have your wherever is your logic, we have to make sure that your app code translation happens whenever you are changing your database engine. So we do have tools that can help you in doing that app code translation. Okay, so from assessment to schema conversion to data migration to app code translation, for all of these different steps, we do have certain tools that can make your life and that can make the migration really, really smoother. Okay, so just to make sure that we have a complete understanding of what are our offerings and to make the migration picture clear. So if you have a MySQL, we have Cloud SQL for MySQL. If you have Postgres, we have Cloud SQL for Postgres. That's typically a homogeneous sort of migration. Or in fact, if it is Redis, Memorystore for Redis. If it is HBase, you can move to Bigtable. But if you want to modernize and you want to get onboarded to a native offering of Google like Spanner or Bigtable or Firestore, there would be certain changes in the schema, like we just saw, right? So whenever there is a engine change or there is a heterogeneous migration, okay, so like MySQL to Spanner or Oracle to Postgres or Cassandra to Bigtable, right? So in such cases, as we just saw, we do have different tools that can help you. Okay, so let's look at one of such tool, which is our native offering of Google Cloud, which is called as Database Migration Service. So Database Migration Service or DMS makes it fast and easy to lift and shift your traditional databases, that is MySQL, Postgres or SQL Server, to a managed Cloud SQL offering. Okay. But how is it great, or what are some of the differentiators that DMS offers? So DMS provides a simple integrated experience to guide you through every step of migration. And this guided experience take you through migration job creation with built-in customized source configuration information, setup of multiple secured networking connectivity options, and built-in scripts for easy executions. And by enabling validation before migrations are run, it ensures migration process or migration success. So DMS is serverless, so there is no migrations servers to provision, manage, or monitor, unlike other offerings. Okay, so it's completely serverless. You don't have to choose a migration instance. In fact, DMS has a self auto scaling feature that ensures high performance uninterrupted data replication at scale. With DMS, you enjoy continuous data replication from source to destination, and you can use this to migrate database with minimal downtime. DMS also supports multiple connectivity methods, and based on the source and the target and where they are, you can choose either of it. DMS is 100% open source compatible, as it leverages the native replication capabilities of MySQL and Postgres for highly accurate and high fidelity migrations. And the best part is it's completely free. Okay, absolutely at no additional cost. You can use DMS and migrate all your open source databases like MySQL or Postgres to a managed offering like Cloud SQL. So these are some of the supported sources of DMS, that is MySQL, Cloud SQL for MySQL, RDS for MySQL, PostgreSQL, RDS for Postgres, or Cloud SQL for Postgres, or SQL Server. All these are the supported sources that currently DMS supports. So while doing the migration, DMS make sure that the downtime is not huge. And how it does is, so DMS, while you configure the source and the target, you have an option called as option where you can choose that you want to do a continuous data replication or a one-time replication. So what it means is, while you're configuring a DMS job, you first go and define your source, right? And then you define your destination, and then you define how you want to move your data. And if you choose a continuous data replication, what it will do is it'll take an entire snapshot of your source database and push it to the target. And say, for example, if you have 1 TB, 2 TB, or 10 terabytes of data, it would take some time to get the entire data moved to your destination. And during that time also, you would, because your source is still serving the traffic, you would get a lot of changed data, correct? So once the initial snapshot is done by DMS, automatically it will start reading for all the changed data, and it will move that data also. You don't have to do anything. Okay, you just have to go and choose the continuous data replication, and automatically it'll take a snapshot and also move the changed data from your source to your target. And the best part is DMS also offers you a lot of visualization or monitoring tools through which you would be able to figure out how much is my lag. Okay, so once the initial snapshot is done, you would see a lot of lag because the changed data is not yet transferred. And once the changed data is transferred, the replication lag becomes 0. So once the replication lag becomes 0 between the source and the target, you can stop writes on your source, point your applications to the target, and just restart them. With this process, you would incur a very, very minimal downtime. Correct? Within just few minutes, you would be able to move your traffic from your source to the target. And with this, DMS also offers minimal downtime and maximum performance and security. Okay, so this is how you can transfer your data when the engines are same. When the engines are different, we have certain tools like Strim, which can help you in doing the schema migration as well as data migration. We have tools like iSpirer, which can help you in doing the app code translation and make sure that your business logic is also transitioned to the transition based on the target compatibility. Okay, cool. So this is what I had, which I intended to cover in this sessions. I think I can open the floor for questions. Please let me know if you have any questions. I'll be happy to answer that. Okay, I can see one question. How is this useful for hackathon? So I'm sure while building your hackathon demo, you would intend to use a database. So based on the overview of all the databases, you can choose the best possible option based on the use case what you're trying to solve. Right. So if it's a simple OLTP use case, maybe you can go with Cloud SQL, because you will be the judges would be evaluating the entire design based on multiple aspects, where scalability and the choice of the tools would also play a very important role. Sure. Any other questions?
Any other questions? Please feel free to ask. Now we have given you the option to unmute and ask your questions, so please feel free to do so.